Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Now, today in this first video lecture of week 12 for the course Biostatistics 1, today we are going to learn about the probability distribution. So, for the probability distribution, first of all, I would like to tell you about the random variable. Random variable, such a numerical quantity whose value is determined by the outcome of random experiment, is called a random variable. Mathematically, we assign a single real number to each outcome of the sample space, and hence we state that a random variable is a real valued function defined on a sample space. A random variable is also called a chance variable, a stochastic variable, or simply a variant, and is abbreviated as random variable or V. The random variables are usually denoted by the capital Latin letters such as X, Y, and Z, while the values taken by them are represented by the corresponding small letters such as X, Y, and Z. For example, if you toss three coins together and let capital X denote the number of heads, then the random variable X consists of the values 0, 1, 2, and 3. Now, another example, suppose that a coin is tossed twice so that the sample space contain these outcomes, double H, HT, TH, and double T, where H denote head and T denote the tail. So when we coin a toss twice, we obtain these outcome for the sample space for this experiment. Let X represent the number of hits that come up. With each sample point, we can associate a number of X as shown in the following table. Thus, for example, in the case of double H, that is 2 hits, X is equal to 2. While for TH, 1 hit, so X is equal to 1. It follows that X is a random variable. So, dear students, note that in this experiment, our random variable X denote the number of hits. So, like you see over here in this table, these are the sample points. So, in this outcome, the number of hit is 2. In this outcome, the number of hit is 1. In this outcome, the number of hit is 1. And in this outcome, the number of hit is 0. So, this capital X represent the random variable. And here in this example, the random variable described as the number of hit in the experiment. Now, distribution function. So this is now actually the probability distribution. The distribution function of a random variable X denoted by f of X and is defined by f of X is equal to probability of all X less than or equal to this small x. And I already told you that if this capital X represent the random variable, in this sentence you see over here, the capital letters X, Y, and Z denoted the random variables, and the value of these random variables are represented by the small values, the small letters X, Y, and Z. So this is the probability values of the random variable, which is less than or equal to X. This small x represents the value of the random variable, and this capital X actually describes the random variable. Now, the function f of X gives the probability of the event X takes the value less than or equal to specified value X. In a probability distribution, the sum of all probabilities should always be equal to 1. For example, you see over here, the probability distribution of a random variable may conveniently be expressed either in a tabular form by showing all the possible values of X and the associated probabilities f of xi is equal to probability of x is equal to xi, as you see over here in this table. Now this is actually the values of the random variable x1, x2, x3 up to xn, and these are the probabilities. F of xi, f of x1, f of x2, f of x3 up to f of xn. For example, we have a problem to find the probability distribution and the distribution function for the number of hits when three balanced coins are tossed. Now, dear student, you see over here to find the probability distribution. First of all, construct the table. So you see over here the problem is to find the probability distribution, and this probability distribution, the random variable description is the number of head. So this is our random variable. The number of head is equal to capital X when three balanced coins are tossed. Now this is the experiment. Three balanced coins are tossed. In this experiment, the random variable description is the number of head. So first of all, we find the sample space for this experiment. The sample space for this experiment you see over here. This is the sample space. When we coin three balanced coin are tossed, maybe we obtain head, head and head for all three times. Maybe for two times we obtain head, and for the third time we obtain tail. Maybe we obtain head, tail and head. Maybe we obtain tail, tail, head and head, and similarly head, tail and tail, tail, head and tail, double tail, head, and maybe we obtain all three times the result and tail form. So this is the possible outcomes for the sample space. Now in this sample space, our random variable is denoted by capital X, and this capital X be the random variable that denotes the number of heads in this sample space. Now you see over here, this X may be 0, the number of head may be 0, the number of head may be 1, the number of head may be 3, the number of head may be 2, and the number of head may be 3. These are the possible number of heads in this sample space. Now X is equal to 0 mean that the number of head is 0 in this sample space. So the probability distribution function f of 0, which is denoted as probability for the random variable x is equal to 0. Now x is equal to 0 mean there is no head. There is no head mean there is only one outcome in which head does not appear. So the probability is 1 over 8, because the total outcome in the sample space is 8. 1, 2, 3, 4, 5, 6, 7, 8. Now random variable x is equal to 1. The number of head will be equal to 1. So the probability distribution function f of 1. Now the probability for the random variable x, where x is equal to 1 mean number of head is 1. That outcome in the sample space in which the number of head is 1. You see over here, head, double tail, t head tail, tail head tail, and double tail head. So there are three possible outcomes in which the number of head is 1. So the probability for this random variable is equal to 3 by 8. Now probability for the random variable x is equal to 2. So all possible outcome in which number of head is number of head are 2. You see over here, there are three possible outcome in which number of head is 2. So the probability is 3 by 8. Now x is equal to 3 mean the number of head is 3. So there is only one outcome in which the number of head is 3. So the probability is equal to 1 over 8. Now putting these information in the table, you see over here, this is the number of this xi represent the number of heads, which is we can say that this is the random variable. Capital X denote the random variable, and this small x denote the values and the number of hit in the experiment 0, 1, 2 and 3. And these are the probabilities. Now dear students, note that sum of all these probability equal to 1. If we add all these probabilities, 1 over 8 plus 3 by 8 plus 3 by 8 plus 1 over 8, which is equal to 8 by 8, and 8 by 8 is equal to 1. Now another example, to find the probability distribution of the sum of darts when two fair dice are thrown, and B part, use the probability distribution to find the probabilities of obtaining number 1 a sum of 8 or 11, number 2 a sum that is greater than 8, number 3 a sum is greater than 5 but less than or equal to 10. Now dear students, the sample space for this experiment, when two fair kind or when two fair dice are thrown, we have all these possible outcomes for this experiment, and we have already discussed this experiment in the previous video lecture, that there are possible 36 outcomes. When we thrown two dice, maybe we obtain 1 1. If we fix the result for the first dice, that is 1, and weigh the result of the second die, we may obtain 1 1 1 2 1 3 1 4 1 5 and 1 6. And similarly, if we fix the result of the first kind and vary the result of the second kind, we may obtain 2 1 2 2 2 3 2 4 2 5 and 2 6. And you see over here, these are the possible outcomes for this experiment, which are 36. Now the sample space is for this experiment of throwing two dice containing 36 sample points. Sample points mean number of outcomes in the sample space, which are equally likely, that is each point has probability 1 over 36. Now our random variable in the first part, to find the probability distribution of the sum of the darts, you see over here, let x be the random variable representing the sum of the darts which appear on the dice. Then the values for this random variable may be 2 3 4 up to 12. So these are actually the values for the random variable. The sum of darts may be, you see over here, the sum of darts 1 1, 1 plus 1 is equal to 2, 1 plus 2 equal to 3, 1 plus 3 is equal to 4. So we obtain the result from 2, 1 plus 1 2, and 6 plus 6 12. So we obtain all these possible values for the random variable 2 3 4 5 up to 12. Now we can start the value of the random variable x is equal to 2. The sum of dart equal to 2. In this case we have only one outcome, so the probability is 1 over 36. Now the sum of darts equal to 3. In this case we have two outcome, 1 2 and 2 1, because in this case the sum of the darts equal to 3, so probability is 2 by 36. Sum of darts equal to 4, so we have these three outcomes, so the probability 3 by 36. Sum of dart equal to 5, so in this case the probability function, and probability function f of 5, which is equal to probability of all probability of the random variable x is equal to 5. 5 mean sum of darts equal to 5. So 1 plus 4 5, 2 plus 3 5, 3 plus 2 5, 4 plus 1 5. So in this case we obtain 4 outcomes, so the probability is 4 by 36. Now similarly, probability function for f of 6 mean probability of random variable x is equal to 6, 5 by 36. Probability for the random variable x is equal to 7, 6 by 36. Probability for the random variable x is equal to 8, 5 by 36. Probability function when x is equal to 9, 4 by 36. Probability when x is equal to 10, 3 by 36. Probability when x is equal to 11, 2 by 36. And probability when x is equal to 12 means sum of darts equal to 12. So in this case we have only one outcome, 6 and 6. So 6 plus 6 is equal to 1, and the probability is equal to 1 over 36. So dear students, in this table you see over here, these are all possible values of the random variable. Sum of darts equal to 1. Sum of darts. Actually the random variable description is sum of darts. So sum of darts equal to 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So these are all the probabilities of the random variable x. So xi actually represent the value of the random variable, this capital X. In this capital X description is sum of darts. Only we have sum of darts. So sum of darts results start from 2 and the end is 12. And these are the probabilities. So we can verify our result that the sum of all probabilities for the random variable values will be equal to 1. So when we add all these probabilities, you see over here 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15, 15 plus 6, 21, 21 plus 5, 26, 26 plus 4, 30, 30 plus 3, 33, 33 plus 2, 35, and 35 plus 1, 36. So 36 by 36 is equal to 1. So our result is correct. We can verify the result by adding all the probabilities. When sum of all probabilities equal to 1, then the probability distribution table will be correct. Now, our another description using the probability distribution, we get the required probabilities as follows. You see over here, uh, a sum of 8 or 11. This is our another description when the sum of darts 8 or 11. So x is equal to 8 or x is equal to 11. And we have already discussed in the previous video lecture that R mean union, and for the union we can use the addition law. So in addition law we use probability of x is equal to 8 plus probability of x is equal to 11. So probability distribution function for x is equal to 8 plus probability distribution function for x is equal to 11. In this case, you see over here, when sum of darts is 8, in this case we have 5 outcomes, like you see over here in the previous slides, when 1, 2, 3, 4. So when x is equal to 5, so when sum of dart is equal to 8, you see over here sum of darts equal to 8. We obtain 2, 6, 3, 5, 4, 4, 5, 3, and 6, 2. So 1, 2, 3, 4, and 5. So in this case we obtain 5 outcome. So the probability when the sum of darts is equal to 8, we obtain the probability is 5 by 36. And when the sum of dart is 11, we obtain 2 outcomes, 5, 6, and 6, 5. So in this case the probability is 2 by 36. Now 5 by 36 plus 2 by 36 is equal to 7 by 36. Now another part, you see over here in the problem that to find the probability that the sum that is greater than 8, sum is greater than 8. So our next description, our next probability distribution is the sum is greater than 8. So x is equal to greater than 8. X is actually represent sum of the darts. Now sum of the darts greater than 8. So in this case the x value will be equal to 9, 10, 11, and 12. So the probability distribution function for x is equal to 9, 4 by 36. For x is equal to 10, 3 by 36. For x is equal to 11, 1 over 36. And for x is equal to 12, we obtain 1 over 36, and for x is equal to 11, we obtain 2 by 36. So when the sum of darts is 9, in this case we have 4 outcomes. We have 4 outcomes, 3, 6, 6, 3, 4, 5, and 5, 4. So we have 4 outcomes. So the probability 4 by 36. When sum of darts 10, in this case we have 3 outcomes, 5, 5, 6, 4, and 4, 6. And sum of darts 11. In this case we have 2 outcomes, 5, 6, and 6, 5. So probability 2 by 36. Now the sum of darts is 12. In this case we have only one outcome, 6 and 6. So 6 plus 6 is equal to 12. Now in this case we have only one outcome, so the probability is 1 over 36. Now sum of all the probabilities for x greater than 8, we have all these probabilities. So adding these all probabilities we obtain 10 by 36. Because in the second description you see over here, to find, use the probability distribution to find the probabilities of the obtaining a sum of 8 or 11, and number 2, a sum that is greater than 8. Now the third part, a sum is greater than 5 but less than or equal to 10. So for this description, now the sum of x greater than 5, the sum of darts greater than 5 or less than or equal to 10. So we can write this description as, now for x greater than 10 we have all these values, 6, 7, uh, and 8 and 9 and 10. Now these are the values where x greater than 5 and less than or equal to 10. So we have 6, 7, 8, 9 and 10. Now in this case, the probabilities for this random variable x, probability distribution function for x is equal to 6, for 7, for 8, for 9 and for 10. Now when random variable x is equal to 6, then probability 5 by 36. When random variable x is equal to 7, probability 6 by 36. When random variable x is equal to 8, for 8 probability is 4 by 36. In case of x is equal to 8, we have 4 outcome: 2, 6, 6, 2, 4 and 4, and similarly 5, 3 and 3, 5. So the probability for x is equal to 8, we have 5 outcomes: 3, 5, 5, 3, 6, 2, 2, 6 and 4 and 4. So we have 5 outcomes. So this is the probability for x is equal to 6, for x is equal to 7, for x is equal to 8. Now for x is equal to 9. For x is equal to 9, we have 4 outcome in the sample space when the sum of dot equal to 9. So sum of dot equal to 9. In this case, we have 4, 5, 5, 4 and similarly 3, 6 and 6 and 3. And for x is equal to 10, we have 3 outcome. For x is equal to 10, we have these 3 outcome: 5 and 5, 5 plus 5 equal to 10, and similarly 4, 6 and 6, 4. So when x is equal to 10, we have 3 possible outcomes in the sample space: 5, 5, 4, 6 and 6, 4. So the probability is 3 by 36. Now dear students, these are the sum of the probabilities for x greater than 5 and x less than or equal to 10. So dear students, in this video lecture you see here, we have discussed the random variable and probability distribution. So the probability distribution function of a random variable x denoted by f of x and is defined by f of x. Actually these are the probability for the random variable x, and this small x represent the values for the random variable. So actually random variable represent our description in the experiment. So we first of all we denote the values of the random variables and then find the values of the random variables, then find the probability of the random variable. And dear student, note that in the probability distribution function, we can construct a table of all the probabilities of all values of random variables, and the sum of the random variables in the table will be, in the sum of the probability of the random variable will be equal to 1. Sum of all probabilities of the random variable will be equal to 1. So this point is very important, and that at the end of the solution of the problem, when we find all the probabilities of the random variable, so sum all the probabilities of the random variables in the experiment, the result will be equal to 1. Now this is the end of this segment. Thank you. Allah Hafiz.